One aspect of digital currency that has received less attention is the practical consideration of how digital currency transactions might be processed in the event of a major outage. We will demonstrate that with Keychain Core, we can conditionally process transactions even while one or more devices are offline. And so what we will show here is stand-in processing transactions between three devices, where we have the consumer represented here by the smartphone, transferring funds to a merchant represented here by the tablet. And in some cases, the transactions will need a third device approval by an approver represented here by the IoT device in the background of the picture here. So we will demonstrate a sequence of transactions through different stages of internet connectivity to show how the system behaves in each case. And this will simulate what might happen in the event of a real emergency, such as an earthquake. So let's get started. We'll begin with assuming all the devices are online, they have internet connectivity, and the consumer will spend money to the merchant. We will start off with a transaction of 400 yen. And as you can see, the transaction has now been completed, as has been indicated by the flickering green light in the background IoT device. Okay, now we're going to try a transaction with a higher amount, whereby we expect the approver to reject this transaction. And again, you see through the flickering of lights in the background, which are now red, the transaction has now been rejected, and all three devices recognize the finality of the rejection of the transaction. And to demonstrate, again, a successful transaction, we'll try 1900 and show that the transaction is now approved by all three devices. Okay, so we're going to repeat that sequence, but now we're going to take the consumer offline. And we'll do that, we'll simulate that by putting the device in airplane mode. And we're going to retry the same three transactions. Okay, this one is the 400 yen. And notice, just like the first case, we found that the 400 yen transaction has been approved and the approval has been recognized by all three devices. Let's proceed with 2100. Okay. Again, like the first case, the 2100 yen transaction has been rejected and the rejection has been recognized and accepted by all devices. And likewise, 1900 yen transaction. It resulted in a transaction approval, just like the first case. And so we notice that taking the consumer offline has had no noticeable effect on the state of the transactions that we demonstrated. We can achieve the same state of the transaction agreement regardless of which protocols the transaction occurs over. This is very important when we start to consider how digital currencies can operate through degradations in services. So let's continue on with our demonstration by also taking the merchant offline. So now we have a scenario where both the consumer device and the merchant device are offline. And let's repeat those three transactions and see what happens. We've just done a transaction with 400 yen, and we've seen that the consumer and the merchant device have agreed on the finality of that transaction. Notice that in this case, there was no flickering in the background because the approver has not received information about that transaction. There's no connectivity to the approver. Also, I should mention that the two devices, consumer and merchant, could establish agreement on a 400 yen transaction because we've configured this demo to allow them to approve transactions less than 1,000 yen. Let's continue on with the 2,100 yen transaction. We notice that the 2,100 yen transaction remains in a pending state. It's in a pending state because for transactions over 1,000 yen, we've configured the system so that we require not only two devices to finalize the transaction, but we also require the signature of the approval device. And because we have no connectivity to them, we do not have that approval that's necessary to finalize the transaction. Likewise, for the 1,900 yen transaction, we also see that that is in pending state. And as of yet, it's recorded by the devices, the consumer and the merchant, but they're still waiting for the approval by the by the approver. Now, if we revert the internet connectivity of both devices, bringing both the consumer and merchant back online, observe what happens to the pending transactions. You saw a series of flickers on the approver device receiving in batch mode all of the transactions that were in pending state, and all three devices were able to reach consensus on those pending transactions, and we see that the 2,100 yen transaction was rejected, whereas the 1,900 yen transaction has been approved. Okay, so with these series of cases that we've done and the transactions that we've done, Keychain Core enables applications to perform consensus and maintain data security over mixed network protocols. Secondly, Keychain Core enables a double offline transaction to be conditionally approved based on configurable parameters. And finally, we were able to resume processing of pending transactions after restoring internet connectivity for each of the devices. That ends our demo. Thank you for watching.